This deals with lesson 2-3. On 2-3, we learned about exponential functions, specifically growth and decay and properties like that. So it says, given the values a and b, determine if each is exponential growth or decay, and write a mathematical limit as x increases without bounds. So there's two things we have to do. So first, do you remember how to recognize if something is growth or decay? What do you look at if it's growth or decay? Less than or greater than 1. Which value? The A? No, not the A. The base. This base right here, would this be growth or decay? That base is decay. What about 5/2? That's because it's less than 1. Decay is less than 1. What about 5/2? Growth. 3/4? Decay. Okay. Pretty simple there. Now, graphing it, the A value is like your initial value. So, just really quickly, I'm going to do very basic drawings for each of these three. Very basic drawings here. Nothing special about them. The A value. What did I just tell you the A value represents? It's like your y1, your initial value. So go plot a point where you think on the first one, I'm going to say -3 is down here. That's -3. On this one, 8 would be up high. There's 8. And the last one, 2, would be somewhat low on the y-axis. So all those are like your y1 value. Now, if it's decay, what does that mean about your graph if it's decay? Leaving. What does it mean if it's decay? Is it that it's leaving the asymptote or approaching the asymptote? Which one is it for decay? Approaching. Approaching. Hey, Dino, can you close your computer for me? So not distracted. We're approaching. So the graph should look like this. Since this is decay, it should approach. Whoops. This should approach the horizontal asymptote like this. Decay approaches the horizontal asymptote. Okay, the next one. This one's growth. What does it mean if it's growth? Leaving. Leaving. So it starts on the asymptote and it leaves it. Okay, and this one, decay. What does decay mean again? Approaches. So it's going to hit this and get closer to that horizontal asymptote. So that's what my graphs would look like. To finish this off, it says write a mathematical limit as x increases without bound. As x increases without bound. Someone give me as a symbol, what does it mean for x to increase without bound as a symbol? X going to infinity. So in all these, we're going to talk about what happens as x goes to infinity. For this first one, I'm going to just call it f. I'm going to call this one f of x. We'll call the next one G and the next one H. What's happening as we go to the right, as x gets closer to infinity, as x gets bigger and bigger and bigger? What happens to the y values? Do they rise without bound, fall without bound, or get really flat? Flat. Flat. With what y value? 0. So that would be the answer to this one. It flattens out on 0 as x goes to the right. Okay, how about the second graph? I'm going to call this one G. What happens on this one as we increase without bound? As we go to the right, what happens to my graph? It rises to positive infinity. It increases without bound, excuse me. Okay, last one. I'm going to call this one h of x. What happens to this one as we go to the right forever? Does it rise, fall, or get really flat? And what does it get flat on? The horizontal asymptote, which is 0 on this.